Cool. Hello there. Welcome back to day 13 of Advent of Code in Go. I'm just setting up today's files because I've had a bit of a busy day and I haven't had the chance to set it up yet. So that should pretty much set it up because day 13 isn't out yet, so I'm just testing it on day 12s, making sure that works. Then just have the command ready once the day unlocks. So we have 10 seconds to go. We're going to dive straight into today's challenge. Yeah, excited. Let's go. Okay, day 13. Here we go. Oh, I'm just looking at the input and it looks like we have some origami stuff or something. Okay, transparent origami. You reach another volcanically active part of the cave. It would be nice if you could do some kind of thermal imaging so you could tell ahead of time which caves are too hot to safely enter. Fortunately, the submarine seems to be equipped with a thermal camera. When you activate it, you are greeted with, "Congratulations on your purchase. To activate this infrared thermal imaging camera system, please enter the code found on page 1 of the manual." Apparently, the elves have never used this feature. To your surprise, you manage to find the manual. As you go open it, page 1 falls out. It's a large sheet of transparent paper. The transparent paper is marked with random dots and includes instructions on how to fold it up, your puzzle inputs. For example, I have positions and fold instructions. The first section is a list of dots on the transparent paper. 0, 0 represents the top left coordinate, the first value x increases to the right. The second value y increases downwards. So the coordinate 3, 0 is to the right of 0, 0. Okay, x, y, as you would expect. I guess flipped from normal maths graphs. The coordinates in this example form the following pattern where hash is a dot on the paper and dot is an empty unmarked position. Then there is a list of fold instructions. Each instruction indicates a line on the transparent paper and wants you to fold the paper up for horizontal y equals lines or left for x equals lines. In this example, the first instruction is to fold along y equals 7, which designates the line formed by all of the positions where y equals 7. Okay. Because this is a horizontal line, fold the bottom page up. Hang on, so I'm just going to count this 0, 1, 2, 3, 4, 5, 6, 7. So we fold on 7. 7 still exists, right? 0, 1, 2, 3, 4, 5, 6. Okay, no, so 7 disappears on the fold. Okay. Some of the dots might end up overlapping after the fold is complete, but dots will never appear exactly on a fold line. Okay, so they guarantee that. The result of doing this fold looks like this. Now there are only 17 dots visible. Notice, for example, the two dots in the bottom left corner before the transparent paper is folded. After the fold is complete, these dots appear in the top left corner because they get folded up, right? These dots get folded up to here, so they show up here. Makes sense? Also, notice that some dots can end up overlapping. In this case, the dots merge together and become a single dot. The second fold instruction is to fold along x equals 5, which indicates this line. Again, there is nothing on that line, as you can see. Because this is a vertical fold, fold left, you have this, the instructions made a square. The transparent paper is pretty big, so for now, focus on just completing the first fold. After the first fold in the example above, 17 dots are visible. Dots that end up overlapping after the fold is completed count as a single dot. How many dots are visible after completing just the first fold instruction on your paper? I actually kind of am thinking of a shortcut, somewhat of a shortcut to do this. Whenever you have a dot, right? Let's say we had a dot here. This is going to be, what is it? 0, 1, 7, 8, 9, 10, 11, 12. This is 12, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This dot right here is 10, 12, right? It's 10, 12. So we go through the fold instructions, right? Fold instructions were fold along y equals 7, x equals 5. So is 12, which is the y coordinate, is that greater than the fold line? Yes, it's greater than 7. So we go 12 minus 7 is where it ends up, right, which is 5. Now is 10 greater than the fold line, 5? Yes, 10 is greater than 5, so we fold it again and it ends up at 5. Now I just want to check this. Does this dot here, 10, 12, which was the original dot, actually end up at 5, 5? So we fold that up and it ends up 2 from the top. No, it ends up 2 from the top. Right, because it's 7 minus 12 minus 7. Hang on, let me do that again. It's the fold line minus the position minus y, which means it's y minus 12 plus y, which means it's 2y minus 12. Okay, so it ends up at 14 minus 12, at 2y minus 12, which means it ends up at 2. So the same for the other one, because it was at 10, and the fold line is 5, it should end up at 2 times x, or 2 times fold line, which is 10 minus 10, which is 0. So does that line end up at 0, that spot end up at 0, 0? Let's see. Here we fold it up and it ends up here. Here we fold it across and it ends up here. And here is indeed 0, 2. Okay, so I think we can do that actually. It says after the first fold, so we'll only do this for the first one for now. I'm also guessing that these fold lines will, like there's nothing greater than 6, 5, 5 times 2 is 13, 10. I'm guessing there's nothing that is 13, like that starts off beyond 13, 10. Because I don't think they're gonna make it like, you can't fold a piece of paper like, I actually have some bits of paper on me. Because the way they designed the question, right, is you fold it up. You could fold it like not all the way, and that works, but I don't think they're gonna make it so that you fold it beyond, and then now you have to shift your 0 like up. I don't think that's gonna happen. So I'm just checking that there's nothing that starts off beyond 1310, which is where my fold line is. And I think it is the case that there's nothing greater than 1310. I see some 1308, 1305, 1307, but I don't think, or 1310, there's actually a 1310, but yeah, there's nothing beyond 1310. There is a 1310, there is no 1311. Okay. So we're going to read everything until a blank line. Okay. Let's process this. So points is going to be an array of xy. So xy is just going to be a struct that has x and y, which are ints. Easy. Range the data. I also want folds. How do we do this? We either have x or y. Yeah, we'll do it like that. We could just be a little bit sneaky and do that. So I'm just going to have keep track of a variable called parseFold equals false. So we're going to say if row is an empty line, then we are parsing folds. So that's just to toggle between the two different parsing modes. So if not parseFold, so we're parsing the dots, Then we say xy, we need a new xy. And then we say we'll scan if the data, and it's going to be like this. We pass it into xy.x and xy.y like this. Hopefully it's going to work. And we append that to points. Otherwise, we're passing a fold, in which case we check the, let's see, I'm just counting the number of letters here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So index 11. If row 11 is an x, we pass it as an x. Otherwise, we pass it as a y. Maybe there's a nice, slightly nicer way to do this. Let's do it like this. It's a little bit nicer. Pass it into dir. We'll pass that into value. If dir equals x, false equals append to it, x equals value. Else we pass into it y is value, and it's not equals, it's a colon. So here we're just going to print out the points, and then we're going to print out the folds and see what happens. Which line is that? 48. All right, these are called XY. I reuse the same data type. Oops, this should be continue here, because we have a 0, 0 right here, which is wrong. So okay, I'm just going to double check some of these values. So the last three values is 229, 430, which is fine. 715, yeah, that looks fine. And then the folds, we have 655, 655, 655, 447, 327, 447, 327, all the way down to 6. So it looks fine. So we just want to fold. So we've parsed the data correctly. So now we just want to do the first fold. Now for the first fold, we decided, yeah, so I'm going to do, I'm going to hack it a little bit and just say max x is going to be, it's going to be folds 0.x times 2, and max y is going to be folds 1.y times 2. So I'm going to make it an array. It's going to be in the y direction, it's going to be max y. And in the x direction, it's going to be max x. Then we're going to say for each point, if x is greater than folds 0.x, because we know it's an x fold, right, if p.x, then we're gonna, oh, okay, I'm just gonna, okay, no, you know what, we'll do it like this. Then x equals 2 times, this is what we said earlier, 2 times the 0 fold minus p.x else x equals p dot x. So actually we can do this here, p dot x, p dot y, and we just do this. We say grid yx equals how many dots are visible? How many dots are visible? We can do this a couple of ways, but I'm actually going to just write it into the array like this. Okay, no, I will just keep a count. Can it go 0? If grid xy equals 0, then count plus plus and grid yx equals 1. In fact, these don't have to be ints, they can be bools, but that's okay. So we're just going to print out the count here. Okay. I guess I'm just going to do a +1 just to be sure. I count 802 dots. Okay, it's good. So that shortcut that I talked about earlier does work. And now it says just finish folding it the whole way. The manual code says always 8 capital letters if you finish the fold. What code do you use to activate the camera? So how do we do this? We need to do this for every fold, right? So for every fold like this, let's see. We need to do a different thing. If we need to check first if this is an X fold or a Y fold. So X fold, if f dot x is greater than 0, okay, so otherwise then here it's a Y fold. If it's an X fold, if x equals, if x is greater than f dot x, then x equals 2 times f dot x minus x. Same thing for the y. If y is greater than f dot y, if y is greater than the fold, we do the fold. And we just do this for every single fold. We don't need to count anymore. What we want to do here, though, is we want to read the code. So we know that x ends up, I'm just looking at my stuff, x ends up at 40. And y ends up at 6. That should run without a without any crashes. Okay, it doesn't crash. So now we just need to print out the grid. Yeah, we can just print it out, I think, for, let's see. I think we just print it out. I think we will be able to read that. Whoops, I need to actually write into it. Okay, I did run into some problems here. There we go. Okay, that's a little hard to read, but it should totally be readable. Maybe use a bigger character. No, the zeros are too annoying. Okay, no, I need to do this properly. Okay, there we go. We'll be able to read this. What? All right, it's not 1, it's 8. Hang on. We'll be able to read this. Strings and runes. All right, the characters are R, K, H, F, Z, G, U, B. Let's go! 800! Okay, we caught up as well because in the first half, yeah, we were beyond it. We were slower than 1,000. I do think that that little shortcut I talked about this, the way that I'm folding it and not actually just keeping on looping over the array and mapping stuff over beyond the line, but folding it, like folding every dot as we go, because that's essentially what this is doing, right? Over here, this is essentially, you see how we range over all the folds for every dot, right? So that means we're virtually folding every dot before we even write it into the grid in the first place. And that's why I can make my grid the smallest. Now, I mean, this 40 and the 6 you can work out programmatically by just iterating backwards through the array and finding the final fold in that direction. And then once you have that small grid, then you just have to, yeah, do all the folds for each dot virtually, right? You're mapping it like this, like mapping it back up or back over until you have it in the smallest bit. That worked because they did say explicitly somewhere in here. Let's see. Right here, they said explicitly that if you have a Y fold, you always fold the paper up. And if you have an X fold, you always have fold the paper left. So we knew that the dots were always mapping to a smaller value than what it originally was. We also kind of validated by eye, right? Just looking at my input, like that the folds, the thing I did with the paper, where the folds don't fold beyond 0, 0, right? They always fold up to a maximum of 0, 0, but never beyond 0, 0, which also helps make this work. We fold all the points up and then we write into the grid. And then we just had this little delay at the end to make it something that you could actually relatively easily read on your screen. And you can read that. Yeah, wow, that was actually quite hype because yeah. As much as I want to, like, I'm always torn between trying to do it as fast as I can and actually making it like presentable in this sort of stream format. And so being able to get that second half before that 1,000 cutoff was actually pretty hype. And yeah. So yeah, really cool puzzle. I really like this one. And I like these ones where you have to like print out the output because it's like a grid and you can kind of see it. Yeah, I have nothing else to add. It was a really fun challenge. If you haven't done it yet and you are going to implement it, wish you the best of luck. And yeah.